better. Well, yeah, thanks everyone for the first meetup of this year. Excited to kind of chat with Hamilton and also, put some names to faces. So to help run this, I guess, is it fair to assume that everyone here has tried Hamilton? Who hasn't tried Hamilton? You could put up a reaction. Cool. All right, so do most sense this? I guess you haven't tried Hamilton yet?
Yep, I haven't.
Okay, cool.
But,
go ahead.
Although I heard about it through Arthur.
Awesome. Cool. Yeah. So yeah, for those who don't know, Hamilton helps data scientists and engineers define testable, modular, self-documenting data flows that encode, amongst other things, lineage and metadata. It's just a Python library, runs anywhere that Python runs, so you can kind of run it and scale it in various different places wherever you have a Python runtime. And so for this meetup today, just going to kick off the session with a bit of chatting with Arthur about how he's used Hamilton. We're going to do a short deep dive on structuring Hamilton projects at a larger kind of scale, and then also do a quick overview of one of the decorators, subDAG, just to kind of explain why it exists, and then talk a bit about some of the roadmap and kind of things we built and done, and then obviously depending on time and things, having a bit of an open mic session where you guys everyone can kind of raise things that you're interested in. So with that, I want to hand it over to Arthur to talk about how he migrated feature calculation to Hamilton. So Arthur, you should be able to take over share screen.
All right, cool.
And then just mention, I guess we'll hold questions to the end of Arthur's kind of session, but feel free to also just write them down in the chat or something so we don't forget. But yeah.
All right. Let me know if you see my screen.
Yep. We had it a second ago.
Oh, sorry, that was me. Let me.
Was it? Oh.
Go ahead. Go ahead again. I think I changed something.
Okay. So it's because I moved the tab around. All right.
We have it. Yeah.
Okay, cool. Great. So, all right. Thanks for having me, guys. Thanks for organizing this meetup. So today I'm going to talk about how we migrated our features calculation to Hamilton. So I'll give you a brief outline of what we're going to talk about. I'm going to give a very high-level overview of what is machine learning and what is feature engineering. And in this talk, we'll mainly talk about feature engineering. And I'll show you a naive implementation of a typical feature calculation job. I'll show you a few issues we had with our feature calculation job, and I'll show you how we switched it to Hamilton. And while doing so, I'll introduce two advanced features of Hamilton. And to wrap up, I'll share with you guys some takeaway and tips from Hamilton. Quick intro about me. I'm Arthur Andres. I'm a software engineer at Tradewell Technologies. You can find me on GitHub. I'm 0x26res. So I'll start with a very bird's eye view of what is machine learning and what is feature engineering. So if you're saying about machine learning and the process of machine learning, broadly speaking, you start with a prediction request, something that you want to make a prediction or a guess on. And then you take this prediction request and you enrich with as much data as possible that is going to be useful for you to make an accurate prediction. So that's called feature engineering. And then you've got your prediction with all this data, all those features, you give it to your model and your model does a prediction. So today we're going to speak more specifically about feature engineering. And I'll introduce some key concepts of feature engineering with an example. In this example, we're going to try to calculate an estimate of the wait time for a taxi. So think of it like if you're Uber or Lyft and you want to calculate how much time the user is going to wait for a taxi at any given time in any given location. So you start with a prediction request. So it's the event for which you want to predict. So here it's a timestamp and a location. So 5:30 in London, 5:45 in San Francisco. And then you want to enrich this prediction with features. So a features is the values that you're going to give to your model as an input to help it with the prediction. And typically, in feature engineering, you will organize your features in different feature views. So feature views are a group of features that are logically grouped together. So you will group them together because the features, the data comes from the same data source, or they share the same schema, or they tend to update at the same time, or they come from the same process, but the same process is calculating them. So here we think about a first feature to help our model is the traffic condition. So here you can see that at 4 p.m. in London, the traffic was bad, whereas at the same time in San Francisco, it was good. Another features that come to mind is how many taxis are available at any given time in those cities. And here you can see, like in London, there's a 1,000 electric cab, no self-driving cab because we don't have them yet, but I believe they're available in San Francisco. And in London, we've got a lot of convertible. It's a very crude example. I apologize for that. So once you have your features, you put them together with what is called a point-in-time join, which is basically taking your prediction request and joining them with your features. So it looks a little bit like that. Here we've got prediction request, all our features, so the traffic condition, the taxi availability, and we will feed that to our model, and the model will make a prediction of the wait time for your taxi. But we're not going to bother about the model here. We just care about putting the features together. So let's look at how you would implement this in a very simple way in Python. So for the sake of this example, we'll start with like something quite simple where all our features are actually stored in files. And we'll load those files and put them together. So we've got 3 different features views, prediction request, taxi availability, traffic condition. We load those files and we put them together. We start with a bit of configuration. We say where all data is stored. So it's stored in a directory called dev, but it could be prod, you could be using S3, for example, and a little bit of context, so the date for which we want to calculate the features. We load the features. So all those 3 features, we load them from a file. Like here, we're using a Parquet file. And then we put it together. So we've got this function that put features together, and it's essentially just doing a merge as of. And that's our code. So, but now let's imagine I want to add a more complicated feature. So this time, I'm not only am I going to load a feature from a file, which is the weather, but I'm going to join it with a taxi availability feature to generate my brand new features view. And so the way it looks is like I load my weather feature. So here you can see in London it's raining, in San Francisco there's some fog. And I'll join it together with the taxi availability. And it's a lot of code, but basically what I'm doing is that I'm checking that if it's raining or not. And if it's raining, I will set the number of convertible cabs to 0 because no one wants to ride a convertible in the rain. And this is my new feature. And so I put my features together and everything is working, it's fine, but it starts becoming complicated as you add more features and you want to control which features you're using in which environment. So because my brand new feature hasn't been tested, I would like to only run it in dev for a few days while I make sure it's working well and it's performing well. So here I'm going to add a feature flag, and then only if I'm in dev will I run the calculation of my brand new feature. And then later in my code, when I put the features together, I also have to check if I'm in dev when I put the features back together. And that's where things get a bit complicated because I move from having this process to having a more complicated process, depending on if I'm in dev and prod. And as you add more and more features, as you have many different people working on new features at the same time, this quickly becomes unmanageable. So just to wrap up, we did a simple implementation of our code that's very imperative, but it became hard to maintain. It's hard to add new features. We're using feature flags, which are typically a red flag in your code. You don't really want them. So that's why we decided to switch to Hamilton, feature calculation pipeline. So how do you move to Hamilton? So you need to reorganize your code. The way Hamilton works is that you build a DAG, an execution DAG, based on different Python modules that you load. So here we start with a module which is called load features. And that module has got 3 functions called prediction request, traffic condition, taxi availability. Each of these functions will become a node in a DAG. The input of this node will be based on the name of the parameters or the arguments of those functions. And then if I add a second module to my DAG, like here combine features with a function called all features will be connected to the output of the function in the previous file that were called prediction request, traffic condition, and taxi availability, again, based on the name of the function arguments. So I create a DAG. What I do with my DAG is that I add those 2 modules, so load features, combine features, and this creates this DAG here. And then I can execute my DAG, and I get the features I wanted. So it's quite simple, and it means like my code is much less imperative. I just write some different units of calculation, and Hamilton puts it together based on the name of the function and the name of the function arguments. So this is great. I've got better organized code. I benefit from what's called dependency injection, which means basically I don't really have to worry about some details about the implementation, like the data allocation or the date. I don't have to carry it around in all my function to pass it to the next function. The framework is doing it for me, is managing those resources and this configuration for me. And also I have this nice graph that is generated by Hamilton that gives me an overview of my DAG, which is quite valuable for documentation. Now, there is some issues with Hamilton that we've noticed at first, that like when I introduced this load features module, I had to write a lot of duplicate code. And the other issue is that I'm still in a quite inflexible situation in terms of which feature I'm calculating in my DAG. I cannot control which feature views I want to run in my feature calculation. So I won't be able to do the thing where I have like some features in dev and some features in prod. So let's see how with some more advanced Hamilton feature, I can solve those 2 problems. So problem number 1, I want to be able to reuse a function with parameterized. So here I've got my load feature module. And so the issue I was pointing to is that I had to introduce 3 different functions like prediction request, traffic condition, taxi availability, and they all do the same thing. So I would rather have just one function and say, look, there is one function, but I want you to do it. Run this function for prediction request, traffic condition, and taxi availability. And that's what parameterized do. So here I introduce one function with one argument called feature view name. And I can project different values for feature view name and generate different functions for it or different node in the DAG for each of these arguments, which means the next time I want to add a new feature that load from a file, I just have to add an entry here. So here, for example, I've added the weather feature, and I don't have to copy paste a lot of code. I just add one line of code and I have a new feature in my DAG. So in terms of how you use parameterize, it doesn't really change your DAG. It's the exact same code that we're running. and the DAG is exactly the same. So that's the first problem solved. Then the second problem is that my original issue is that I wanted to control which feature I'm using in dev and which feature I'm using in production without having to use a feature flag, just using basically a list of the features I want. So with Hamilton, when I introduced the node that was putting the features together, I ended up with quite an inflexible function called all features, where I cannot control which features I want. And if I wanted to add a new feature, I would have to either rewrite that function or make a copy of it with more features as input, and then it will become like quite unmaintainable quickly. So that's where Resolve comes along. I'm warning you, like, this is a bit of a mouthful, and it's quite hard to wrap your head around the decorator that it works. But basically what it means is that I can control dynamically which input all the function all features has in Hamilton. And what it means is that now when I'm building my DAG, I can put into a parameter called features views here, the name of the features I'm interested in. So here I said I want traffic condition and taxi availability. I pass it to the driver in the driver config, and also enable the power user mode because this is a powerful feature. And then I can control which features are being used in my DAG. So currently it looks like this, but then if I want to add a new features view easily, I just add a new module explaining how I want to calculate this feature, and then I add the features I'm interested in my list of features views, pass it to the DAG, to the driver when I build the DAG, and then the DAG will update automatically with my feature. And so I can do that for dev. And then when I'm in prod, I can just use a restricted list of features. And the DAG will be pruned accordingly. And I won't be running the new code that I hadn't tested yet. But still, I'm using the same code base, and I'm not using any feature flag to control those features. And for us, when that was the main reason why we migrated to Hamilton, like being able to control which computation we do in a declarative way, not using features flag and not having to worry about what needs to be removed from a computation in one environment or the other was very powerful. So to wrap up, I'll give you like 5 takeaway from our experience migrating to Hamilton. So the first one is that I don't recommend trying to re-implement something like Hamilton yourself. Originally, we thought like, our feature calculation framework is like simple, but we don't really need all those complicated things that Hamilton is going to bring. But actually, just like, for example, being able to visualize your DAG is very powerful. All this DAG execution thing is actually more complicated than you think originally. So you might as well try something that has already been tested. And also, one important thing with Hamilton is that it's a very lightweight library. So it's not like you're bringing a lot of junk to your code base or to your virtual environment in Python, or it's not like you're going to be pinned to, for example, an old version of pandas or whatever that might happen with other tools like PySpark or whatever. So it's not very intrusive in your code base. Then in terms of developer experience, you get very good error messages from the library. So whenever you do an error, when you build your DAG, it will tell you where, it will tell you how to fix it. And if you're still stuck, there's a very responsible community that will help you in the Q&A on Slack. So I recommend, like, if you're not already on it, to join this Slack channel if you're a Hamilton user. And then, like, Hamilton is sort of a mindset you need to get used to. Similarly to the first time, for example, you saw a recursive function for the first time, it's sort of complicated and hard to wrap your head around it. But the second time, you know what a recursive function is, and you know it works, and Hamilton is sort of the same. So it's a mindset to get used to. Then there's 80-20 rule, where 80% of the time in Hamilton, you're going to do like some plain Hamilton stuff. So you're going to write a function, and it's going to be a new node in your DAG. And 20% of the time, you need something a bit more advanced with decorators, like the two we just introduced. And those decorators, like they've got maybe a steeper learning curve, but they are actually very powerful. And to finish, like one of my apprehensions I had when I came to Hamilton is like, it's sort of opinionated in how it works. It's like, oh, you need to rename your function so that they are the name of the output. And then you need to change the name of the arguments of your function. And you're like, oh, I'm going to have to change my whole code base to use Hamilton. But that's not true, because at the end of the day, you're not going to put your whole code base in a DAG in Hamilton. What's likely to happen is that you'll have one part of your code base with your core utility or your business logic. And this doesn't really need to care or know about Hamilton. You can call your function whatever you want, and you don't need to import anything from the Hamilton framework. And then at the edges of your code base, you will create some specific module for Hamilton to put together your DAG, like we're doing here. And this sort of needs to, like when you write this code, you need to be mindful about how you name your function, how you name your argument. And you may need to import some stuff from Hamilton, but this is going to be, at the end of the day, a tiny part of your code base. And also, if you already have existing tasks running that are not using Hamilton, you don't have to migrate the whole task to Hamilton. You can just take a part of the task that is the most complicated, or the task for which you need to control dynamically which computation you want to do, which is what we did. We're not using Hamilton everywhere, but we're using it where it's the most useful to us. So that's it. Hope you enjoy that talk, and I'm sure you've got some questions. So
awesome. Thank you, Arthur. Questions, anyone? Roel, did you had one?
Yeah, I was because I'm working on something similar. And I recognized the all features node that I had in my DAG before. And I was actually on Slack, and I'm not sure who of you guys proposed it, but I used the custom adapter to basically join this stuff together, right? Could that be another approach? So basically, when you run your DAG, you specify which features you want to compute. So you specify the nodes that you want to compute. And then as a post-processing step, in the adapter joins it together. So it joins together the features that you want to create, right? So then you still have the flexibility to only compute the features that you want, and therefore prod, be very explicit about it, but still have that final result that comes out of your run. So that could be something that might be interesting for you too, Arthur.
Yeah. Yeah. So yeah, I guess. To paraphrase Roel, I think, there's several ways you could have implemented your problem. I think the resolve decorator is definitely one way, and one way to have it fixed in the node. But Roel was saying that if you can actually build an adapter and pass it in, that if the data frame is the last thing you're getting, you can actually have a custom reduce step, and so you can then dynamically join things kind of there as well. So that's kind of, I guess, what I took from your comment, Roel, and then Arthur, does that make sense?
Yeah. Well, I think here, for example, if we look at this slide, I think you could change what is in final vars to be the list of features you want, and then have the adapter put all of those together, like from a dictionary or from a data frame.
Yeah, but one thing I liked also about your presentation, Arthur, is like the 80-20. I've been spending a good amount of time on rewriting the docs. So if like there are things that are unclear or that would need more examples, ping me also on Slack. I built a function modifier page, which is already like a step above writing one function, one node, but there's also like a advanced function modifier page, and like resolve is definitely up there because like it's very powerful and can be scary at times. But you should, everyone in the call, I don't know where you're in your Hamilton journey, but like getting started usually is pretty easy, but you will find points where you're like, hey, it's painful to work with Hamilton. Then it's probably a good time to like review the docs, and there's probably a solution, or just message us on Slack. So,
to add to the point about the different ways of doing it with an adapter or a sort of list of final bars or doing a resolve thing, it depends a lot on the approach of like when you need it. So for instance, if you want to do it as an intermediate node, it's not going to work in final bars. So you might want to do something more like what Arthur did. So all sorts of ways to use it.
So Raul, did you have anything to add? Cut you off, I think.
No, I really liked the presentation, and it sparked me to look at the parameterized functionality again, because like you're saying, there's so much functionality, there's so much possibility, so it's sometimes hard to kind of have it all in your head, like what to use. So thanks for sharing.
Go ahead, Dima.
Yes, sorry guys, I'm embarrassed. I'm not, probably the only person that I'm not having used Hamilton, but it came up as a question is, okay, we have a DAG, we have formalized the flow of processing. What about versioning of data? Like, I guess you have an instance of a graph, which is a concrete Hamilton defined object, wrapping your function, etc. Is that at any point capturing versions of input somehow so that you can reproduce what you're running, and you can, because the features, that's the thing, the features, a lot of times you have to generate and regenerate and regenerate and track the evaluation, the performance metadata, but then you have to use different versions of data possibly to fully reproduce apart from just code. Is that something that Hamilton does, or is something that tools that Hamilton works with do as well?
I might answer this one. Actually, like there's two parts. Maybe like Archer can speak to, or Royal, I believe, like can speak to the versioning of your code and how you move towards deploying new versions of your features. But for the running code based on the version of like your data, we just released a caching adapter. We actually have two different caching adapters based on your specific needs. So you could look into that, or again, ping us on Slack.
Thank you.
Yeah, because I guess Hamilton doesn't really take any, doesn't have an opinion about where your data comes from. So it's up to you really to tell, oh, I want to load the data from this version. And it's also up to you to have the lineage when you save your data at the end of Hamilton, to be able to tell, well, this data was done with this version. But one thing that's good with Hamilton is that because you've got this dependency injection aspect of it, is that the version becomes an input to your DAG, and then any node that needs to care about the version can be given the version very easily. Which is much harder if you write a lot of imperative code. If you write a Python script and you carry around the version and need to remember to pass it to all the functions, like here Hamilton will do it for you. So
Cool. Well, if there are no more questions, we'll move on to, I guess, the deep dive. Oh, Adam, go ahead.
Maybe one more. Thank you.
Yep.
Good evening, all, or good morning, depending on the time. I have a quick question regarding performance. So after you mentioned that you migrated from existing XG solution, can you elaborate maybe on the scale of basically the computations and if you observe any changes in performance?
yeah, so I mean, I guess like the scale of the computation is it's a job that takes 1 hour to run, mainly because like some of the intermediate feature calculation can be quite complicated, and really Hamilton didn't occur any, like when you look at where we spend time on, it's not really in terms of orchestrating those different nodes in the DAG, but it's really like each node does a lot of heavy lifting on the data, complicated calculation. So there isn't that much of overhead in terms of performance when it comes to Hamilton. And we're doing something like a single process in Python and then leveraging like libraries like pandas or polars or arrow to do the computation. I know that if you care about performance and want to speed up some jobs, like I think Hamilton can be useful because it's got other executors that can parallelize some nodes calculation. It's not something we have done, but it's something that can be valuable to other people.
We would be interested actually in the Spark driver for sure to use it. So I'm not sure how it's scaled yet. For that one, maybe question to you guys. Do I need to use data frames? Is the preferred way actually to model it?
From our experience, you can use whatever you want. We use actually, typically we would use arrow tables just because we care a bit more about the schema of the data, but you can use any arbitrary data you want.
I was going to say Spark is slightly different because Hamilton would delegate to Spark for the underlying actual execution and things. So you have to think in data frames a little bit more with Spark because you can't actually subdivide a data frame into columns like with pandas you can do. But happy to. We have docs and other things that examples we can point towards. But otherwise, Sholto, go ahead.
Well, thank you.
I just wanted to get a bit more context, but I could probably follow up with other docs. Is if I remember reading correctly, with the like the Spark way, you have to use column series objects rather than data frames, or are you able to actually do the computation with the data frames?
So. Yeah, so we had a blog post about a specific integration with Spark that allowed you to do columns, but many people will start off with data frames. So the common pattern is you'll have a Spark data frame, like one node that's a set block of data frame computations, and then you split that into two, you do sort of different computations, and then you join them together later. Now, if you want to do sort of very specific feature column level operations, where you want to do like a DAG of columns and you don't want to break it out into a bunch of different sort of series, because that's inefficient in Spark, we have an integration that allows you to define that, and we sort of do a compilation step where we run it all in a DAG and do a sort of topological sort of it. So
awesome, thank you.
Yeah, I just dropped a link to the blog post on specifically the PySpark kind of integration that Elijah was talking about. But yeah, a lot of feature computation you want to model as columns, not as whole data frames, right? And so what that blog shows you can kind of interplay between, do you take in a data frame or do you try to think more in columnar? But
it also leverages pandas UDF, so you can hop between sort of pandas and Spark. So you could have like a columnar feature engineering thing in pandas that you run and you test out locally, and then when you want to run bigger data, you run that as part of a bigger Spark DAG. So different options there.
Oh. All right. Cool. Well, thanks, Arthur. I'm going to take over sharing again. For this next section so we put out a little, request for comment on, what to deep dive on. So one of them was kind of just how to mentally structure projects. So I think this kind of dovetails a little bit with what Arthur was suggesting, but maybe, be curious to hear people's thoughts. Feel free to interject and, ask questions if things aren't clear. And then I'll try to time manage things so that, we can get things done, because I feel we've got about another 40-ish minutes or of what we scheduled. So my mental model, or at least like the kind of the way that we design Hamilton, was that, at a high level, you write functions, but you have to organize these functions into modules, right? And so hence therefore, like, how you structure, a bit like how you structure your Google Drive or your file system, like you end up having to kind of slightly think about how you going to structure your code base as you're putting functions into modules, right? At a core level, so I have an end-to-end machine learning pipeline here on the right. With Hamilton, you kind of have the flexibility of like, is this all this code, all these functions in one module, right? Or maybe you could, organize these functions into, n modules, or it could be 3. So maybe you organize things into, data loading, feature engineering, and then, like model fitting or kind of prediction, right? And so that's kind of, like at a high level, in a nutshell, is like, yeah, you, because of the driver, right? You can pass in as many modules or as little modules as you kind of want here. It means that, you can play around with how you structure what functions you put in which modules, right? One of the things to think about scaling this, and kind of what we've seen kind of generally work well, is that you effectively start to group functions into thematic modules. So like, say if you're doing a lot of feature engineering, one of them could be, like, I guess, weather features. The other one could be market features. The other one could be, road features, right? And so you start to kind of group functions and things kind of thematically. One of the implicit things that kind of, if you're familiar with object-oriented programming, there's a construct, building an interface, which you kind of have to implement. What you're kind of doing here with these, as you're building modules, is that the name and the type of what a function depends on effectively becomes an interface. And so this means that you can achieve modularity by, so if I want to change how things are loaded, as long as you can't really see this here, but as long as I write a module that outputs a passenger data frame function that is of type data frame, I can swap this module out for a different implementation. There's also an @config when annotation on a function, which can conditionally swap out nodes. So if you wanted to like not create a new module, but like change an implementation of a specific feature or etc., you can kind of do that. But I will pause here and see if people have questions or people are confused or.
Hey, Stefan. I think I'm the guy who requested this, so thanks. One thing that we've been thinking about is we're building more of a larger self-service platform using Hamilton, where users may only have exposure to one business domain, right? And I think one of the challenges that we're thinking through is the namespacing. So let's say I have a node called customer ID in one module. Users may want to combine modules across many different domains. So how do we resolve that conflict in naming, or try to namespace it in some way?
Yeah. So caveat is, this naming constraint, right? And so the original intent behind the naming constraint was, given an output, how can you quickly and easily find the definition of the code for it? So that is really kind of the impetus of the constraint. And so really part of it, it's a kind of a bit of a question of, it depends on context a little bit, right? Part of it is like, are you thinking in columns? Are you thinking in data frames? Those have different kind of implications, right? Gary, did you want to jump in?
Yeah, quick intervention maybe for those who are less familiar. Like, one thing to note with naming constraints in particular is not only the semantics, but they have to be valid function names, or like function parameters. And so it's also a nice like constrained naming space where like you're mostly using underscores and like nouns and verbs. So
yeah. So so part of that is like, if you are mutating customer ID into many different versions, then maybe, to me, those should be different named columns, right? So if you're mutating something in general, then it feels like, for debuggability and maintainability, it should have probably be, named something slightly different. The other is you can help rename things at data ingestion time, so you can prepend or things that to say they're not processed, and then once they're processed, they have the proper kind of schema name. But then there's also, depending on the context of reuse, there are decorators like subdag and pipes. So a classic example being, say you have a generic model fitting pipeline that doesn't care about the features, all you get is a data frame, you split it, you maybe change some models, but like you want to, you want to construct many different models. And so one of the things you can do is you can, parameterize a particular module or sub part of the DAG, in which case things then are namespaced under that sub DAG. And so you can then have, multiple nodes that are called training set, but like they're namespaced under something. So to your particular question, Ryan, like a part of it, I want to say it depends a little bit on context and what you're trying to construct and what you're trying to expose. Since this is where either there's a particular methodology in Hamilton, or maybe we need to add something to the framework to make that a little more ergonomic. So definitely, I want to say the feedback appreciated, but if I want to say if you had some code example, that'd probably be the easiest to kind of ground and kind of talk through. But there are, I want to say, different avenues, but it kind of largely depends on context. So and what I mean by different context here is like if you have the same feature title, but it's based on it's actually based on a different data set, right? Then maybe you shouldn't have those two functions in the same module. You should be in different modules because you'll construct the graph differently based on context. But does that help at all, Ryan? Or are you confused?
Yeah, definitely. I mean, I think it goes back to naming things is hard. So yeah, there's good patterns here. I mean, one project we had, we literally just added a prefix to all of the features to differentiate, which works in some cases, but we're just trying to think other contexts. What are some of the other options? So I think I'll definitely explore subdag a little more and see how that may help.
So we have the next slide is on subdag, right?
Yeah.
Perfect.
Well, I can. Yeah, I was just gonna. Well, you're gonna do the next one.
Yeah. I mean, so high level in terms of like the way that I like to think visually, right, is that with Hamilton, you're constructing anything that can be described as a workflow or a directed acyclic graph. You can construct those. You can take portions of that graph and stick them into modules. Then you can kind of fashion them as Lego bricks. These Lego bricks can be standalone, like you can instantiate a driver just with them. This is one way that potentially you can split up work between teams. So like, the data eng team owns the data loading modules, and then the data science team owns, the feature engineering modules. And then all you have to do then is align on like the output schema or like the final things. And then you can kind of plug that into Airflow pretty easily, or take that and plug it into some other place. It's not true also that you have to run everything right with Hamilton, because with Hamilton you can have this giant graph, but if I only want to compute some of it, like Hamilton will only walk the graph for what you compute, what you requested. So this means that also you can have you can run this. So you can define this graph in multiple, say, tasks in your model fitting pipeline, but only run different subsections of it. And one of the things I should put on the slide, but if you're doing that, then overrides is a bit of something that you can kind of use to inject things into the graph. So like a previous computation. But this is, I guess, the other way that we've been thinking about as projects get bigger is that like, you don't have to run the entire graph. You can run subsections of it, and then the only caveat is really kind of around naming and things. But questions? Anyone? Moving on. Go, Schulte.
Sorry, I'll do a quick one. Just with the subdags, I've found that you obviously have to call it around a function, which means that only one function can receive the results of like a subdag execution. Is there ways around that, or is it best to basically wrap your results in that function and then extract them outwards if you need them for like further processing?
I will defer this question until we have I guess specifics on the subdag decorator. So with some code, maybe that might help ground a response.
Perfect, thank you.
But otherwise, so like it's Stitch Fix. So just to give you a sense of scale, like the team we built Hamilton for, like, was managing 4,000 feature transforms in a single repository. They had to come up with a naming convention for functions. So for example, the underscore meant dummy variable, and different thematic functions and features were named kind of appropriately. What they ended up doing is having a lot of modules, but then hierarchically grouping them into sub packages. So one of the things you can kind of do is you can create some sort of parent package that has an init function that imports the functions that you want. it could define them or pull them in from other modules, and then in your driver, right? This is one way that you can, like, if you have a lot of features and you don't have to specify 10 modules, it's one way that you can kind of wrap them up into a single module. So this is one way they manage to scale 4,000 feature transforms is by grouping them into modules and then grouping them into kind of packages, then importing the right package at the right time. Gary?
Yeah, just to be specific here, like usually people suggest not using import star, but that what it will do is like put everything that's in the child1 and child2 namespace and put it in the init file. So that's why in the driver code, when you import parent, you're actually importing the content of all of the child, just the children, to be clear.
So there's one way. And then the other is, at driver construction time, you can actually script the set of modules you want to import. So you can use import lib, which is one way to dynamically import modules. And so this is, if you have therefore a list or a config of modules, right, you can then dynamically import it. You don't have to actually hard code it in your driver script. So this is then another way that you can then, get around the scale, or at least like not having to actually import everything or have it specified. You can kind of have a bit more configuration driven. And then with Hamilton, though, you don't have to make a decision up front. You can change things over time easily. So with naming, right, it's just largely find and replace in a code base. And then you can also then just move functions around to other modules, right? This is where Hamilton, hopefully, if you when you're building the DAG, will tell you if you're missing something, or you've defined things in two places, in two different modules, right? Hamilton will kind of tell you that. Otherwise, so this was kind of Konstantin. Yeah.
I want to just ask one question. Do you see any caveats in the approach when I want to put every function for each function in separate module? I see some pros in that. It looks like documentation of when we have a lot of functions, it looks like documentation will be more clear when in documentation for each function we have just one link to one separate file for that function, and if they are shared, when the several data analysts work on them, for them it would be easier to find the function to work on them, to work on them together. I mean, so, but are there any problems with that?
I think it's an interesting approach. I think the upside is that you won't get merge conflicts ever. The downside is that you're going to have a lot of files. So it depends how you like doing it, and you're going to be like managing both the files and the functions. So Hamilton sort of generally we've seen people group it together for that reason, so they don't have to manage a lot. But I can see some advantages to independent things living independently.
Yeah, I was going to say it's Stitch Fix. We actually set up Sphinx docs, so it would build from the Hamilton modules. Would build docs so then people could search and find kind of features and documentation for them. But I want to say if you take Hamilton or like the modules to the limit, you can put one function in one module, but then you're effectively then in your import of the driver doing a lot of different things. And so in which case we have found that no one's really needed that level of granularity. And so in which case thematically grouping into modules is probably the 80-20. Or you go to the one side where it's just one module and all functions. So but Hamilton forces you to at least separate it from your driver code. So that then it's at least easy, more modular and reusable from that perspective.
As a former Java developer, though, I see the appeal of one function per module. It's like the same thing with classes. You'd have like all these little files. Oh, so
okay, thank you.
That's a good question.
Any other questions on that before?
So I'm glad we got some questions about subdag. because it's a pretty powerful feature. It's a little complicated in how it works. As you can see, there's a lot of the design of Hamilton is the 80-20. So you've got the 80 of like plain functions, as Arthur said. And then if you need to start doing sort of more complicated stuff or support different use cases, we've got all these decorators to help out. So yeah, so the mental concept of subdag is you're basically using a driver within a driver. So you can sort of instantiate a set of functions and have them live inside some piece that'll then get fed into a function. So pictorially, you'd have instead of having like a whole DAG that lives in the same thing, you'd have like some sort of piece of a DAG that you're using to power a function. You want to show what it looks like in subdag? Cool. So yeah, subdag exposes the visibility to a single DAG, or in a single DAG, and it ends up namespacing it. So what it does is it's effectively syntactic sugar for sort of reusing a set of functions, perhaps with a different config, and passing in a different set of inputs. And the way this works, and this gets to the point about living in a function earlier, is that you declare a function that says what it wants out of that subdag. So this is saying there's a subdag, it takes in the module feature modules, you inject the path from the source path variable, and you stick that into feature modules, and then it doesn't have a config, although the configs can sort of change how it shapes. The important thing to note that has confused people in the past is that what you're doing is you're taking the output called feature df of feature modules and passing that into that feature engineering function. In this case, it doesn't do anything with it. You can do some sort of post-processing piece, right? So one way to organize, so this allows you to say, I want to rerun all of these sort of functions and just take out these pieces that I need. So you can sort of use a subset of it. You can have multiple of these refer to the same set of functions if you want, with different parameters or even the same parameters. There's a lot of things you can do with this. But Ryan, getting to your question, and this may or may not be an interesting approach. I think it could be useful if I understood correctly. If you want to say, like normally we use this for reusing different pieces. But if you want to do it solely for the purpose of namespacing, this is actually a fairly reasonable way to do it, because subdag will namespace it, meaning it changes the node names to be like the subdag name, which is feature engineering based off the name of the function, dot my node, meaning that you now can reuse different node names and have fully independent modules. So if you wanted to, you could have like 10, 20 modules where you don't care about the naming constraints in between, and then have one subdag for each of them. Now you lose a little bit of visibility, because if you want to look at the individual pieces, you have to like go in and determine like this namespace plus the name of the node itself. And it's generally a little more static which ones you get out of it, although there's a few ways around that, possibly with config and whatnot. But it's an interesting approach. So it might be worth digging into. I think we could also consider something that would just like auto namespace a module, but there's a few interesting issues with that. So ways that people have used this in the past, you can use subdag if you want to say like do a few different variants on a feature engineering, do model training with a different algorithm or with a different set of parameters, and stuff like that. Even like some file processing where you load some set of files and do some processing with it, and then you want to load it from a different source, or you want to like, oftentimes it'll be like you have 3 different sort of data sources that go through mostly the same transformation. Subdag is a good way to do it, so you can keep those the same.
Yeah. There's also parameterized subdag. So
yeah,
if you end up repeating things in subdag, there's also parameterized subdag.
And you can and if you want to get crazy, you can combine that with resolve, in which case you have now a configuration-driven parameterization of subdag. But if you get to the point where you're doing that, come see us, because you might be over-engineering it. So,
Shelter, did this answer your question? Does this help?
I was more just because over there you're kind of using the subdag just for that feature engineering function, and I found that I've had to maybe use one item in that subdag for one function, and then another item in that subdag for a different function. But maybe that's more down to the design of the project rather than the use of the subdag. Yeah.
Yeah, so just to be clear, you can pass in functions or modules to that first parameter there. It's a variable argument name list. So you can, I'm not sure if this is what you're saying, but you can have like feature modules 1, feature modules 2. Yeah, a few different. So if you want to post on the Hamilton Slack are open up an issue. Happy to sort of do a bit of a deep dive later.
Yeah,
Or
no,
code review. Feel free to use the Hamilton help in Slack to double check code. Just to kind of visually,
To look at it, here's what it looks like. You can see we've got subdag there that takes in A, B, C, and D. And you can see the namespacing there, right? So the end ones are subdag 1, subdag 2. This also happens to generate it for A, B, C, and D, which is a little bit of a weird thing with subdag, because those are also independent functions that it calls it. Usually you'd put those in a different module or sort of names, stick them under a thing. But anyway, you've got 2 subdags, the left one and the middle one there. You can see they all end at subdag 2. There's subdag 1 and subdag 2, and the other ones are namespace. So this is how, Ryan, you might get it, sort of namespacing them. You can see that they'll share a name. They'll share that sort of like suffix name between subdag 1.a and subdag 2.a, but they'll actually be different nodes. And you can request them directly, so they're not fully hidden.
Question on that. So let's say I wanted to access subdag1.c, just in another Hamilton function. Is that something you could do and say, I want that as my input? Obviously, I think the dot might break Python's.
So there is a way to do it,
but
using another decorator. We recommend against it though, because of the sort of notion of encapsulation.
Okay.
Now there is a way to do it using something called inject, where you're not bound by the same Hamilton names.
I mean,
little like power user mode.
I mean, the way that I could, so Hamilton only computes what's required, right? And so if you're only computing this part of the subdag, you don't need the rest of it, right? I'll just change what you're requesting here, and then you just whoever's downstream will just depend on this function instead.
Okay. And I guess the larger point is if you have sort of dependencies between subdags, then it's going to force you to really think about the naming point, where you might have, if they're like operating fully independently, then it might make sense to share some sort of names, right, and not worry about the naming thing. If they're operating with touch points between them, you might actually really want to start thinking about the names. And then I think this kind of pushes you to do that.
Yeah, I think conceptually, I think a lot of this analogous to building a data warehouse, for example, right? I may have many tables as my source that have similar column names, and I can, through namespacing, access different values from each of them, and then you may want to alias this table and so on. So I'm trying to figure out how to do something similar with Hamilton, where we have a lot of sources with similar column names, and be able to request, hey, I want this input from this one source.
Yep.
Yeah, I mean, love to chat after to help figure out if there's things we need to make that easier. Just looking at time, so we got like I guess 15 minutes, and I just wanted to briefly. This is where talk about things that we've done and kind of doing. So some of the recent highlights is with your help and kind of input is we @tag now supports a list of strings. So if you have properties, right, you can now kind of tag something with a list of strings. If you want to custom style the graph as output, you can now effectively pass in a little callback function that will kind of do it for you. And then you can also export, have a JSON representation of the entire graph and kind of code that's being executed with a new function on the driver. We also built a lightweight little app, right? Lightweight experiment tracker. So if you want something lighter weight than MLflow, right? Would love thoughts or your reactions here. So this is a little fast UI and fast API kind of app that with one line addition to Hamilton, you can kind of track things too, and then see what's going on. We've been trying to add a lot more examples to Hub. So the Hub, with the idea being like examples that you can pull off the shelf. So a little bit more, you could say, specific DAGs that could be reusable components or things that you want to start with. As mentioned kind of earlier, Terry mentioned we've been doing some documentation refactoring, so try to really make it easier. And then we also helped, we've exposed some more lifecycle APIs. So for example, with one line change, you can now get, as your DAG is running, a little TQDM progress bar, right, that can tell you, where things are going. And then also if you want to like plug in Datadog and get spans, right, we have an integration there. And then this morning we released a new disk kind of or caching adapter. So another kind of, I guess, trying to work on ergonomics and development to make it easier to dev pipelines or Hamilton DAGs without you having to really rerun things. And then, of course, we've been trying to write blogs for that showcase different things you can kind of do. So one call out. So at DAGWorks, right, we have been working with a few other companies as design partners to more tightly kind of help them integrate Hamilton. This has been great for figuring out how to shape some of the open source stuff. So if you would like a session with us, or you want better help or support with what you're integrating, do feel free to reach out. Otherwise, with what we're building, there is a free tier of observability and introspectability that you can get if you use Hamilton and then you do one-line addition to DAGWorks. We would love feedback. So feel free to sign up, play around. This would be kind of helpful to us. But otherwise, in terms of things on the horizon, we've been trying to focus on making the time to aha for people who are new to Hamilton to make it easier and better and faster, and so also help champions such as yourselves if you're bringing in Hamilton to make it easier for you to kind of convince and have the material to help others along. So we've been focusing on documentation and examples. But otherwise, we kind of need your input and ideas to help prioritize things to add kind of to the framework or integrations, right? And so this is where just listing some of the ideas here, they aren't listed in priority order or anything, but if you're interested in Ray and Dask, like we could build better integrations there. If anyone's on Snowflake, we would love to have a Snowpark story. Maybe you need more data quality integrations or pluggability. You're using Great Expectations or something, like we'd love to try to make that easier. With Hamilton, you write functions that are unit testable. Maybe we can make it easier to generate unit tests or stub them out for you. And then also better workflows or things or CLI tools we could add that would potentially help with your workflow of how you're integrating and running Hamilton. So I want to say I've thrown a lot out. Don't need to answer right now, but like if you have ideas or thoughts or concerns or things you want to raise, like would love either you can start up a GitHub discussion, you can start up a discussion in Slack or GitHub issue, or feel free to shout things out here.
One of the upcoming posts is a small CLI tool, and we hope to have a nice util for people to be able to diff two DAGs or like two revisions of files that you have on Git. So we think it could be nice to see like which node were added, removed, edited, and if it has impacts on downstream nodes. I think that would be very helpful for CI in general. So we're excited for that.
As a Mad Lib, if it was like, I wish I could do X, or wouldn't it be cool if, this part of my workflow would be easier? That's, we'd love to hear them if you have thoughts. So, what else do I have? Oh, yeah. So, anyone have any strong opinions or thoughts on like, hey, things to add to Hamilton? Otherwise, yeah. Got one vote for monitoring usage. Yep, Sholto, go ahead.
I was supposed to do it in the chat, but I was quite excited about that notebook development that you guys have started with. So actually being able to integrate it with Jupyter notebooks, it's really, awesome.
Cool, thanks. Yeah. So the Jupyter magic is, I guess the one thing I didn't add is that we recently released, but yeah, you can now, we're trying to make it easier for you to like create modules on the fly in a notebook and then have a prescribed way to like then, write that module out or take it to production in a way. But yeah, looking for more feedback as to things that would be useful and easier to help develop. We also have a very nascent VS Code plugin, which I would love input and feedback on if that's something that'd be of interest. But
the VS Code plugin is on the ice right now, but if there's some users that want to give me some feedback, I can put some grease to the wheel
and help develop it.
And if people have any sort of tips and tricks or tools that they've built to help Hamilton development, we'd love to hear. We'd love to. A lot of what we've added to the library has actually been user contributed instead of tools to aid development, and that's the best way to to add new features. So reach out, happy to showcase it, happy to get it into sort of extensions of the library or into the core library.
Yeah, I think Elijah, Stefan, and I are like always very excited about building new features, but it's even better if like other people benefit from it out the gate. So just ping us and let us know what you feel is valuable to you right now.
Yeah, Constantine.
Yeah, just a small addition. I very liked your introduction about your thoughts about how to organize code. So I suppose it would be great to have a page and documentation about best practices of code organizing. I think it would be very useful.
Yep.
Yeah,
I think we have one page on naming convention, but it's like, yeah, I think it's I don't think I have what the slides that I have. I think we could easily turn into documentation.
Yeah, to Royal's point, when you say monitor usage, I imagine like who's importing what module and what features. I think it's something that we've thought about also that's been an idea, is just like having a guide or a blog post on how teams can maybe have feature repositories on GitHub, and like how you can manage like from a platform side what's being used downstream and keep track of that. So that's also something that we can work on.
Yeah. Yeah. So to elaborate a bit on it, I've actually built a wrapper around Hamilton, right? Which is kind of a feature catalog. So people use Hamilton to build, well, to compute different nodes, basically. And one person computes this part of the DAG, another person that. And I want to be able to see like, okay, well, how are people using it, right? So what is being computed, so that I can also make a clear story on maybe what part of the transformations need to actually be stored on a platform and not be kind of dynamically computed every time. Thanks. So that's it. So I'm not sure what part can actually be in Hamilton and what needs to be outside of it, but
no, I mean, yeah. So this is where it's like our intention is always to have Hamilton be a lightweight library, but I think the ecosystem of tools and plugins, like this is where it's like having optional things you could spin up and integrate with is really where I see some of this work potentially being as well. Otherwise, I mean, in terms of ideas, Royal, like if you, I don't know if you checked out DAGWorks, but like, we can take ideas from what we're building close source and also, talk about, how we can add things to open source as well. So, we're very open to that. So, otherwise, apropos, Royal is actually going to be talking, next month on, again, around features, but I guess a little bit more about what we've been building. If there's anything else to add or say to that, Royal?
Yeah, on the spot.
It's okay. You can just say the title says it all.
Yeah, I mean, I think there's some similarities to what we've seen today, but definitely also there's different perspectives. And I think also I've learned some stuff today. I think every time people use it in many ways, and I think I'll try to put a few different angles on it.
And Roel, you've been really digging into the PySpark world, so I'm super excited about that.
Yeah, using it with Spark indeed.
Cool. So I mean, this comes us to the end. I guess this is where maybe for next time we probably need to maybe block off a little bit more time, maybe for the meetup. But like, if you have things you want to chat about, or like this is open mic, or like in general, community calls. So this could be even like, hey, I'm looking for a job, or I have job postings, or other ideas for the community. This is, I guess, a time and space for that. So, does anyone have anything they'd like to raise, chat about, talk about?
I want to thank everyone for showing up. Like we were a bit like nervous because like you have 100 people saying yes, I'm going to be at the meetup, and you never know what's going to be the turnout. But like it was great to see you all and have this participation today. Thank you all.
Yeah, I'll just say thanks for putting this on. I think it's been great, as well as the Slack has been really helpful. And maybe a topic for next time, or something that I would really like to understand, is polars and how to best use Hamilton with lazy computation plans. I think it's probably similar to some of the PySpark, so maybe we'll see that next month. But trying to conceptualize that and having more examples around that, I think would be really helpful.
Awesome. Noted.
Yeah, that's great. In the meanwhile, we do have some examples that we can point you in your direction. So
awesome, thanks.
Yeah, we have an example that uses a polar series, but we've been talking internally, like there's a way to delegate like polar's expressions through Hamilton. So you write the expressions, and at runtime you have polars and all the lazy computing. So we're looking into that too.
Okay, yeah, that'd be great. That's what I've been thinking about, is how to gather all of these expressions and collect them all at the very end, maybe through a custom result builder. So I love anything on that.
Yeah. Otherwise, quick poll: would office hours be interesting to people for like community, open source office hours? Would people be interested in having something that's like on the calendar, like say maybe once a week or maybe once every 2 weeks? Or just general help and chit chat. All right. As long as one person finds it useful, that's fine. That's good enough for us. Jordan, go ahead.
Maybe it was showing.
Oh, just showing your hands. Perfect. Yeah. Office hours sounds good. No worries, Jordan. Thanks.
Just wanted to thank you all for being part of this community. Always awesome to see Hamilton users out in the wild. I keep discovering sort of new use cases, new ways that people think about it, which really help improve the platform. So hopefully many more of these.
Cool. Well, yeah, we'll be around if you want to chat, but if you, I guess have to go, feel free to leave. Thank you for joining, and I'll stop the recording as well.
Bye.
Thank you all.